Hello everybody and welcome back to Property Data and Tools. And today we're going to check out cross-correlation multicollinearity. What does that mean? We have a multi-parameter space and are looking if one or two or many parameters are cross-correlated. Are they moving in the same direction? And that's what we're doing. I already loaded the required packages here in R and are now also loaded the data. You can see there's property dataset, as well as a subset of 5,000 sales observations. The next what we do is we are subsetting this and we only look at certain values like transaction values, area size, bedroom, bathroom, has a fireplace and so on, to then look if there is a correlation, and we create a little cross-correlation matrix where we have a matrix which is defined by all of the parameters in X and Y dimension, and if they are correlating with each other. Correlation, of course, in that case are only working with a continuous parameter, so binary or discrete parameters are not possible to look at. So let's execute this, and we are getting a core matrix where we are seeing the Pearson, not Spearman, correlation. The diagonal fields, as you can see, are always 1 because the bedrooms are 100% correlating with the bedrooms themselves. The same then is okay. We see that some are positive correlated, some are negative correlated, some are strongly correlated with, for example, here transaction value versus distance to CBD. Others are not so strongly correlated. For example, if it has a garage and transaction value. So each one of those numbers is the correlation between one of the parameters and its counterparts. That is very hard to read. Coreplot is a package which allows you to look at this a bit more visible. So let's look at it. You see on the right side here, we have seen now a new plot which has all of the parameters and how much they correlate as indicated by color, positive or negative, and strength is indicated by the diameter of the circle, which is quite handy. So what we see is the first thing is that the distance and the transaction value is negative correlated very strongly. Bathrooms and transaction values as well as bedrooms are correlated. And what we also see is that there is a cross correlation between bedrooms and bathrooms. That can explain you sometimes how that one parameter is dependent on another parameter. That doesn't mean that you can remove it. That is a little bit of a question on how we select significant parameter. So feature selection is a term you can Google for details. Another way to look at it is we're looking at a pairs panel. Here we go. This pairs panel is again the same thing. We have the transaction values and how much they correlate with the bedroom, for example, 0.18. Also the distribution. We see a frequency distribution in lines. If you make it bigger, you can see it better, as well as bar charts, and then the distribution as the data as a whole. So you see there's a scatter plot for each one of them on one side, and on the other side the correlation indicator. Sometimes these correlations are not linear, and that helps then to look at these transaction versus distance to CBD. What we see is that distance decay is not linear. It decays faster at the beginning and then slower at the end. And that's also what we're expecting from our previous weeks, where we looked at the log transformation as a more precise approximation of the correlation between transaction values and CBD. We can save this as a CSV or as a PDF here. Like here as you see, you can write a PDF and you always have to open the PDF, what you're going to do, and then close the PDF. That's the same thing here for the next one, and we can always save them. As an advice, generally save it as PDFs and not as JPEGs. They are much more sharp because they are saving vector-based files and not pixel-based files. So you can zoom in, and you can also just take a sample of it. If you want to have only one of those distributions, you can still use it. While when you're doing a JPEG, you have to redo the whole thing. Part 2, linearization and variables to improve the residual fit. What we are creating here is a linear regression model. We know that already. We create something here. We create a model. LM is the function. Okay, 1 second. I have to rechange the parameters. So we look at the properties, or properties for sale actually, because there is a parameter, as you can see, that there is not found. CBD to distance to CBD is not found, and this is because we changed the name distance to CBD underscore M. So we also have to include that like this. So distance CBD underscore M. Let's check that. Yes, that's it. Let's execute the same function again. We have another nice little linear regression model with significant and not so significant parameters, which are giving us a R-square of 0.397, which is nice. This is okay. But let's plot this. Again, we plot this. What do we get? We get the residual fit, and what we see is that we're overestimating the lower prices and then underestimating the middle and then higher again. So there is something happening. We see that the error, you have to think about the residuals as the errors which you're having in your prediction versus that what is in your data. That there is something, because there is some sort of pattern. High, low, high. So something is not right. Okay, let's look at the next part. This is our QQ plot. In our case, we are not expecting truly a distribution which is following a Gaussian bell curve distribution. This is what this does. It compares quintile to quintile from your data set or your residuals with your normal distribution. That's what this does. We're not expecting that. And again, we see that there is something happening. This is again showing the residuals and the prices. The last one is the Cook's difference, or the Cook's distance, which shows if you have an outlier which is skewing your results. We don't really have that here. Mostly this is the line which you're looking for, the 0.5 values. Anything above that will skew your model. So that's okay. What did we learn? We learned that there is something happening, especially because of that first plot where we see the residuals versus the fitted values, and we see that trend line going down and up again. Sorry, that was the wrong one. That was too far. This one. And here you see that trend line. There is something happening. So maybe there is a problem. And the problem is in that the one parameter is not correlating with another parameter in a linear way. So we have to adjust this. We actually can do that, and we do that here. First we look at this. We look at distance to CBD versus transaction value on a scatter plot. So let's execute this. First we create that data set, then we create the scatter plot. Again, we have to change the parameter name. I should have done that before. My apologies. We'll get there. And voila. The computer is calculating. And is showing this. What is happening? So what we see is a trend line in blue. But if you're looking at the values, transaction values versus distance to CBD, you can see that there is something wrong. We underestimate the distance, underestimating the distance in the distance, and we overestimating at the beginning, and there's something off. So maybe the correlation is not linear. Let's remove this. And we can look at this and just change that the distance to the CBD is maybe a log of the transaction value. So we create exactly the same thing. Computer is calculating. Let's see if it's big. Let's see. And we see that our trend line is now much more through the data set. It's much closer to the points themselves, and that's what we want. We want to have a close proximity between the trend line and the individual points. Well, maybe we get it even closer with our last version, where we are taking the log of the distance and the log of the transaction value. There we go. Let's zoom in. Let's put it big. And what you see is that there is a much closer distance between the points and the trend line. And that's what we want. So let's use this in our regression model. Instead of having normal properties for sale, transaction value and CBD distance, we can change this to transaction value in log and CBD distance. So let's see how that works. The first one and the second one executed. So we get an R square of 0.3967, and the other one is getting much closer. You see the R square, we are much closer between the two. Let's see if that works as a log-log, if that still improves our, again, my apologies, I seem to not really learn from my errors. CBD underscore M gives us the right, there we go. And we're even increasing it slightly better. So we get to 0.55 before we had 0.5. So you see that already by changing certain parameters, collinearity, we see that there's something happening. So first one, we get suddenly a much closer fit. Our errors, our residuals are now homogeneously distributed along the zero line. So they have exactly the same amount above as below. That's what we want. The QQ plot is a little bit better, but that's not what we're looking for. We don't really care about this right now. And here we go. We have maybe there's still something happening. What we see is that there's a positive trend between the standardized residuals and the prediction values. So there might be still parameters which we might want to include. And we are very far from any kind of Cook's difference. This is very good. So we have no parts. Okay, this is it. This is how you change if you have a parameter which might not have a linear correlation between another parameter to a potential function, for example, a log or an exponential correlation. This is very helpful in cases where you have, for example, distance to the CBD. Why is that helpful? Because if you're going further away from your CBD center, the area where you can actually build upon is growing by square, because you're talking about an area. So kilometer away actually makes your area which you can build on much larger. So therefore the supply increases not linear but exponentially, no, in polynomial. And this is why we have to use the log. Helps us getting that into check. Thank you very much, and see you next time again.